Okay, so we're looking at this pivot table that we set up in the previous code, in the set of code that we have here for pivot 4, which appears here in our global environment, and the code that we had set out here grouped by class and by point of departure, and then we estimated the mean fare. We aggregated these categories by mean fare. We counted the number of passengers. We arranged by P class, so first class, second class, third class, and then we have it in the viewer, in the RStudio viewer. I suppose what we might observe here is the Cherbourg seems to pay more than Queenstown and Southampton in first class. In second class, Cherbourg paying more than Queenstown and Southampton for second class. In third class, Cherbourg paid less, so it was cheaper to come in third class from Cherbourg. Cheapest of all from Queenstown, and Southampton the most expensive. Okay, so there's a little bit of interesting pricing here. And if this was a small data set relating to pricing, we could kind of apply the kind of typical type of marketing type analysis here too, varying price points. Cherbourg seems to be the most expensive, except when we come to third class. Not obviously evidently the case that then Southampton is. Not so many. If we look at Queenstown being in Ireland, only 3 people went in first class. That looks quite small. Only 7 people went in second class. Again, looks quite small. In third class, most of the Irish passengers who boarded at Queenstown, that's where the bulk of those passengers are, and that might just reflect the economic context of Ireland at the time. That Ireland was relatively poorer to its peers in UK and in France. Okay, so that again something a little bit of economic history perhaps there that we might extrapolate from. Okay, so the pivot tables here are useful. Let's do the same again, but for the median. And again, a similar type of pattern emerges. The Queenstown ticket generally looks cheaper than the others. Okay, let's go back. And again, is there a link between fare, point of departure, and survival? And let's view. So this is a little bit more involved, because now we have an extra or a new column here relating to survivorship and where you embarked from. When we break it down, probably isn't that evident here. So when we look at Queenstown, 1 embarked, they didn't survive. Another 1 embarked, they did. So 2 survived from Queenstown in first class, 1 perished. For Cherbourg, 44 perished, but 97 were saved. And from Southampton, 99 in first class were saved, 78 perished. Okay, so nothing immediately of interest perhaps or striking. When we look at second class, Cherbourg 12 perished and 16 survived. From Queenstown, 5 perished, 2 survived. When we look at Southampton, 141 perished, 101 survived. So I don't think we can, relative to point of departure, we have strong evidence to say that highly influenced. Now maybe we need another visual or a metric, but from the pivot table, just in a very cursory fashion, maybe there's not strong evidence that the point of departure influenced outcomes. Let's just see in third class here, 391, Cherbourg 37, Queenstown 40. Those are the ones. Okay, these two 47, Southampton 104. So I think we probably need a different metric to capture that. And then the pivot table does the same again, but I just done it for median. Okay, so it's just an extra layer of, again, follow the same set of code, but just differentiated in terms of this is mean, this is the median. Now, if we do have, okay, let's say we do run this and we get pivot 7, fair 7, and we did find that particular data set interesting for whatever reason. We could explore it. If we go to our files, you'll notice here, this is what's in the folder. I can write that out. I can write the data out to the folder. When I set the working directory, I set it to the source location. And if I write that pivot table 7, if I want to examine that in Excel, let's say, I could write it out as a CSV file, and let's just run that to see what happens. So let's run, and when I run, you can see it appears over here. Okay, so that now is a CSV file that's now in my source folder, and I can open up that in an Excel file. Okay, maybe I'll pause just to show that. So it does appear in the source folder. When I open that up, this pivot 7 now appears as a CSV file. So I have that in the source folder, and we can examine the detail there if needs be. So that's something of interest. Okay, so let's go back into R for a moment. And yes, in this set of instructions, I took this from, I'll give the web reference copy, and we'll go into Datacamp and just paste go, and I took it from this snippet here, and I just found it a little bit interesting, and I borrowed the code. So if you want to explore this set of files and graphs and so on here, there's a little bit more explanation that might be useful to you, right? So that's Datacamp. Datacamp is a nice place if you want to learn Python, SQL, some other data science tools. There is a subscription fee, and something that occasionally when students ask me where they might start, I sometimes suggest a Datacamp because it's a very joined up and pathways are provided for training. Okay, let's go back then to our studio for a moment and just look at want to set up we want to look at the age and then the fares. Okay, and some interesting data here. Some people paid in excess of 500. We might like to break that down along can we differentiate male from female? So we include this bit of syntax here. Again, the ggplot is reading from this data set, and it's saying put age on the x-axis, the fare on the y-axis, and we're going to apply color. And because it's geom point, it is a scatter graph. Okay, so we can improve the visual here by adding a little bit of color. So the female is red, the male is blue. We then might do a fast trap where we break apart the males, those who survived from those who perished. Okay, so exactly the same, but we add the facet grid, which will subdivide our graph here between those who survived and didn't survive, and perhaps we can say something that answers, the question, is fare here influential and age for survivorship? One of the things we observe is that those who paid the 500, there was 3 people, passengers, who paid in excess of 500. They all did well. They all survived. Then when we come down, typically the cost of the fare is sub £300. If you were female with this type of ticket, you seem to have done remarkably well, and one male survived, right? And the males who paid these tickets here, they mainly perished, and one female perished. Okay, so for this, between £200 and £300, females did really well, males did quite poorly. And then as we go down through, females seem to have done quite well here. The males badly, with some exception. Females here perishing. So they drowned and they survived. The females here broadly did well. The males, the females here, not so few perished. Most survived with that type of ticketing. As we go down through into the second class and the third class, you can see females survived a little bit better. A few more males here. And then in third class, a lot of females would appear to have been a lot of females with the lower tickets, costing tickets, they didn't do so well. Okay, so that might be as expected. Again, I also went back to Dave and found this interesting source. I'll just copy and take a look at Dave. Now, Dave is free, right? So unlike Datacamp, there are some free samples of instruction here on Datacamp. They're worth looking at. But Dave in the Data Science Dojo, this is free, and I just took Dave's code and I followed a little bit what he did, and again produces nice graphs and some additional pivot tables. So you might take a look here at what Dave has to offer. One of the things that he makes clear in his presentation here to Excel users is that R, according to the rankings of IEE, R is quite a strong performing programming language in particular for data science. Okay, so we go back into R here and we'll look at, so what we're going to do here is we're going to take males and split them out, create a new data set where we exclude the females. Okay, so let's just run that. And now you can see we have males here. There's 843 males, 14 variables. If we take a look, they're all male, right? So everybody here is a male, and there's 843 of those. And okay, we might say summary of the fare, and the average fare and the median and so on, we get report down below. So maybe I can come down here and you can see the minimum fare. Some men paid 0, which is unusual. Perhaps that they were crew. The quartile, we had the box plot a moment ago, but the first quartile and the third quartile relatively low, with a median of 1188 and a mean of 26. We could take the standard deviation here, and we could take the length, 843, and then we do the same for females. We splinter out the females, exclude the males, so that'll create something in a new file in our global environment. Let's run data frame in our global environment, and then we do summary. And if we compare the situation between the females and the males here, the lowest fare for females was £6.75. The median was substantially higher for the females than the males. We saw that before. The mean was substantially higher for the females than the males. The third quartile higher, substantially higher, the maximum being the same. Okay, so there was and here we had one male that we don't know the fare. It was non-applicable. Standard deviation here, 63 for the females, and the length 466. Also relative, so there's 466 females, 843 males, maybe 844 if we account the NA that appears here. Okay, so this is something that's is important. In the next snippet of code here we have family size, and if we go into Dave Langer's dataset, he explains in this how this is estimated in this video, Introduction to R Programming for Excel Users. I'm going to follow up on that in the next video clip for Tidyverse.